Hello everyone, now we are going to discuss the next topic, that is energy method. What is energy method? Basically, we are going to use energy method in order to finding out the natural frequency of the vibration. Since we are discussing the natural vibration, so we know that in natural vibrations, what is the condition? In natural vibrations, if I'm talking about the friction, in natural vibrations, so you all know that in natural vibrations there is no friction. In natural vibrations, we don't consider kinetic friction, or you can say the kinetic friction. We can say the kinetic friction is equal to zero. Yes or no? I already told you the two conditions in the natural vibrations, that kinetic friction is equal to zero, and the external forces equal to zero. Okay, so this is the kinetic friction is equal to zero. If there is no kinetic friction, you are able to understand that there is no energy losses, because energy loss is in terms of friction. If there is a friction, there will be an energy loss. Okay, but in case of natural vibration, there is no kinetic frictions is there, so that means there is no energy loss. Okay, so I'm just writing that next point is energy loss. Energy loss is equal to zero. Energy loss will be equal to zero. Yes or no? If energy loss means change in energy loss. Okay, you can say change in energy. If the change in energy is equal to zero, that means there is no energy loss. That means energy remain constant. So the next thing I can write that energy is equal to constant. Yes or no? Since in the natural vibrations there is no kinetic friction, you all know that in the natural vibrations we don't consider kinetic friction. So in natural vibration, if the kinetic friction is zero, and we know that energy can be lost in the form of friction. Okay, so if there is no kinetic friction, there will not be any energy loss. Okay, energy loss means what? Change in energy of the system. If the energy loss is equal to zero, that means there is no change in energy. If there is no change in energy, that means energy is constant. Are you getting my point? Energy is constant. Or I can write it as dE upon dt is equal to zero, because energy is not going to be changed. Energy is not going to be lost. So the thing, if energy is constant, so I can write it as differential would be zero. Yes or no? This is the mathematical expression. Okay, so this is the important mathematical expressions in energy method. You must remember that. We will use this expression for solving the question. Let me give you the conditions. Let us consider a spring mass system. So I'm just going to consider here a spring mass system. There is a spring which is having a stiffness and mass m kilogram. Okay, so this is the mean position. This is the mean position. When you release the system from the mean position, there will be a displacement. And the new position, for example, this is the new position of mass m block. Okay, and the velocity is v. This is at time t barabar t, and this is at t barabar 0, and the displacement is x. Okay, so at t barabar t, that means at t is equal to t, what is going to be happen? There is an energy of this mass having. Are you getting my point? At this point, the mass m having some energy. So what is the energy that mass m contain after the displacement x time t barabar t? Okay, so it would be E is equal to half and v square. This is the energy of the system, complete system. We are going to find out this is the energy of the complete system. So the energy of mass having at this point, that would be half mv square. But we are talking about the system. So in the system, mass is there as well as spring is also there. So spring is also having some energy considered as potential energy. So that means half as x square. Now these two energy are there, the kinetic energy of the mass and the potential energy of the spring. There is no other energies there. Are you getting my point? So we have written the energy. How many energies are there? The first is kinetic energy of the mass and the potential energy of the spring. Now what is the energy method? We are going to apply the energy method. So in the energy method, we know that dE upon dt is equal to 0. Yes or no? This is the concept of the energy method. dE upon dt is equal to 0 because energy remains constant. So if dE upon dt is equal to 0, that means this is our value of E. Now you just have to differentiate it with respect to time, nothing else, and you will get the value and we will get the final result. Okay, so here dE upon dt, that means, so I'm just differentiating of equation number 1 with respect to time. 1 by 2 m 2v, the differentiation of v square is 2v and dv upon dt. Okay, similarly plus 1 by 2 as the x square 2x dx upon dt, and that is equal to 0. We just have to differentiate it, nothing else. Okay, so here you can see that 2 and 2 will be cancel out, 2 and 2 will be cancel out. So the remaining things, that would be mv dv upon dt, mv dv upon dt plus s x dx upon dt is equal to 0. If you see carefully these equations, we know that v is equal to dx upon dt. Yes or no? We know that v is equal to dx upon dt. Okay, and what is the acceleration? A is equal to dv upon dt, dv upon dt. So how can you write acceleration as x double dot? X double dot means differentiation of displacement twice, 2 times. So that is the x double dot, okay, which represents the acceleration. So these two things we know that. We just have to put this value here and we will get m x double dot dv upon dt is x double dot, and I'm just going to take a velocity as common plus s x, that is equal to 0. Velocity cannot be equal to 0. That's the equations would be that we'll get here mx double dot plus sx is equal to 0. Now we got the equations of the natural vibrations. This is the equations. We know that this is the equations of the natural vibration. Equation of natural vibration. And we are using energy method. And if you get the equations of the natural vibrations, now you can calculate the natural frequency of the system. So that would be omega n, that is equal to root of s by m. So this is the natural frequency. Either you can call it as the frequency of natural vibration or the natural frequency in terms of radian per second. Okay, the unit is radian per second. So our intention was to find out the natural frequency of the system. Okay, and the thing is that we have applied the energy method to finding out the frequency, natural frequency. When we will solve the questions, I will let you know how to find out the natural frequency by different methods. So we will you can apply in the examination, you can apply either energy method and simple procedure, or we will see the next methods after the energy method. So you have a choice to apply the methods, which methods you want to apply to finding out the natural frequency. Okay, so this is not a complicated one, just you have to practice a lot of questions in each and every method. Okay, so I hope you will understand this complete energy method, because again I'm explaining that in natural vibration there is no kinetic friction. We know that if there is a kinetic friction, there will be energy loss. If there is no kinetic friction, there is no energy loss. Okay, so energy loss will be 0, and if the energy loss will be 0, can see here, if the energy loss will be zero, if the energy loss will be zero, that means energy is constant. Okay. So if the energy is constant, in the mathematical expression, I can write dE upon dt is equal to 0. Yes or no? If dE upon dt is equal to 0, that is the energy method. You can say this is the main concept of the energy method. Okay. You have to apply this dE upon dt is equal to 0 and you will get the questions in the examination. Okay. So we just have applied here dE upon dt is equal to 0 and we will get the equations, and we know that how to calculate the natural frequency when you find out the equations of natural vibrations. Okay, so this would be the procedure of the energy method. I hope you will understand this complete procedure. Now we will do the questions of this method, so it will be easy to understand. So thank you.